Hi guys, in this video we'll see about what is load flow analysis, how it integrated with geographical information systems. By using the load flow analysis with the GIS application, we can identify where are the voltage drops or any transformers are overloaded, how balanced in the system. First we'll see what is load flow analysis. Load flow, that is a power flow analysis system, fundamental tool in electrical engineering to study electrical distribution and transmission system. It tells us how electricity moves through network grid. It calculates voltage, current, power factor and losses in the electrical network. And it helps in a network planning, load balancing like a three-phase, balanced and unbalanced, and fault tolerance. In a load flow analysis, the main methods are Gauss-Seidel, Newton-Raphson, most common for complex networks, fast decoupled load flow, and current injection, most common for distribution networks. Traditional versus GIS-based load flow analysis. In the traditional analysis, we use softwares like ETAP, PSSC, MyPower, or SIPDist, which model the network as a one-line diagram, that is a single line diagram with the nodes and buses. Here I shown just roughly single line diagram how it look like. In this method, it's difficult to include spatial accuracy, asset metadata, and dynamic field data. GIS-based load flow integrates these factors by using the real-world location, condition, and connectivity of every asset. The below you can see the GIS network on top of the base map. Next we'll see GIS-based load flow analysis. Network modeling. Every asset like a feeder, transform, a substation, switch, line is modeled geospatially. Assets have both spatial geometry and electrical properties like line impedance, phase, load, and all. Topology building, that is line and node relationship. The line means transmission line and a node it is a pole or bus. Okay, phase connectivity, whether it is R, Y, B, which phase it is connected. Again it's a three phase or single phase based on that. And open close switch status and breaker status. Load assignment like consumer indexing, billing data, MDM system. Estimated demand, diversity factor or peak demand. So in the dynamically we can pass these load assignments to the load flow analysis. Analysis engine integration, that is GIS doesn't always calculate a load flow on its own. Needs power system core engines APIs integration, custom Python or JavaScript that reads GIS data, perform analysis and write results back. Results visualization, that is voltage levels, transformer loading, line losses, feeder impedance, under voltage or overload voltage zones. GIS based load flow integration you can see. So GIS interface, it's a geographical information systems visualization of the network and the power system core engines. Using the API we can integrate. Okay, as an input parameter will pass the pole load details and HTLT lines and transformers, phase, load, power factor and all. So it the power system core engine it will execute and revert back the four voltages and under voltages details that we can plot on the GIS interface to visualize. Challenges in a GIS based load flow. Data accuracy. If you have wrong phase or wrong impedance, the results will be wrong results. Topological error. Open switches not modeled. That means a disconnected network. It will form the islands. So if many islands are there, mean the load flow it won't converge and it won't give the actual results. Integration complexity. Getting GIS to talk to load flow, that power system core engines, it will take time because it will converge the bus system with a matrix and it will take time to converge the results. GIS plus load flow. Load flow analysis is crucial for a network grid reliability and planning. GIS brings spatial intelligence and real world context. You can implement a GIS based load flow using ESRA or GIS packages or GIS small word or any open source tools also for a GIS visualization. It requires a good data model, clean topology, and a strong integration between GIS and power system core engines. Thank you very much. Please subscribe and watch the videos. I will come up with many more videos on GIS, Geographic Information System, and energy sector, utility sector. Thank you.